Greetings, people of Earth and astronauts of all ages. Welcome to Spacecraft. Hello everyone, Science Officer Millie here, reporting from inside the Milky Way galaxy. Now, our Milky Way galaxy is a collection of stars, about 100 to 300 billion stars, that make up our stellar city. Now, if we think about our home planet, Earth, as being like our house, and our solar system, all the different planets orbiting our star, the sun, as sort of like our neighborhood, our galaxy is a huge collection of stars that make up our city, if we were to write out our home address in the universe. Pretty cool. Now, a lot of you might be fairly familiar with all of the different planets in our solar system that orbit around our star, the sun. But what you might not know is there are a lot of other planets out there in our galaxy that orbit different stars that are outside of our solar system. And we call these exoplanets. Now, I like to remember this because exo means outside, kind of like how bugs have exoskeletons. They have skeletons on the outside of their bodies. Exoplanets are planets that are outside of our solar system. They have their very own suns that are completely different from our sun. Pretty wild to think about. Now, there are an estimated 44 billion Earth-sized exoplanets in our Milky Way galaxy alone. And when we think about that there are trillions of other galaxies out there, there are a lot of other planets out there. So many that our brains can barely handle thinking about them all. Now, to get us started, I'm going to show us some of my favorite exoplanets that we have found so far. Now, the first planet we're going to look at is Jacques 504b, the pink planet. Now, this planet is about 4 times the size of Jupiter, and like Jupiter, it is made entirely of gas. It orbits a star in the Virgo constellation that is actually quite like our sun in size and temperature. But unlike the planets in our solar system, it is bright pink. Now, we don't actually know why. It's not made out of bubblegum, we know that much, but it's a mysterious planet that glows a dull magenta color. Pretty cool. Next planet is 55 Cancri E, which is nicknamed the Diamond Planet. Now, you're probably looking at this picture and going, why is it called the Diamond Planet? It looks like a hunk of fire and rock. And you're correct, it is a hunk of fire and rock. It's not sparkly and pretty like diamonds, but we think underneath the surface there is a layer of diamond. How does this work? Well, we think that this planet is made up mostly of carbon. Now, carbon is an element on the periodic table, one of the fundamental building blocks of matter. Everything in the universe that we can see and touch and feel is matter, and elements are all the different types of stuff that make up this matter. Now, we can put elements together to form molecules, the basic building blocks of life. And life on Earth is primarily carbon-based. And when you hear that, it just means that carbon is the primary molecule that bonds together to form all the different things that make up biological molecules, so all the molecules that are in our bodies. Now, if we take the carbon out of this molecule, it's going to take a little bit of breaking apart some chemical bonds here. Let's get some more carbon. So much different atoms that we gotta break apart. Carbon. Now, carbon usually appears black, like this carbon that I have here. An example of carbon is coal that you might get in your stocking at Christmas time. Another example of carbon is when you have a campfire and that black stuff that's left over when you burn the wood in the fire is mostly carbon. Now, if we put carbon under a lot of heat and pressure, we get something pretty cool. We get, wait for it, diamonds. Now, we think that the core of this planet, which is mostly carbon, has been under so much heat and pressure for so long that it has become a layer of diamonds. Pretty neat. This is all thanks to the carbon that is inside the planet. Now, the next planet is called Kepler 16b. And if there's any Star Wars fans watching, this is a particularly exciting planet for you. Now, I am a huge Star Wars fan. I've been watching Star Wars since I was about 4 years old, and I was very excited to learn that this planet has been nicknamed Tatooine by the Smithsonian Institute. And the reason for this is similar to Tatooine, the sandy planet that Luke Skywalker is from in Star Wars. It has 2 suns. It orbits a binary star system in a circumbinary orbit, which means that the planet goes around both suns at the same time. So if you were standing on the surface of Kepler 16b, looking up majestically into the sunset, you would see 2 suns burning. Pretty cool. Now, this next exoplanet also might be of interest to you Star Wars fans out here. I have nicknamed this planet Kylo Ren. Now, its official name is TRAPPIST-2b, and it is a gas giant similar to Jupiter and Saturn, but unlike Jupiter and Saturn and other gas giants like the pink planet we just saw, it doesn't reflect much of the starlight that hits it. In fact, it only reflects about 1% of the light from its sun that reflects off of its surface, making it appear darker than black acrylic paint. It is very, very dark, and no one knows why. So that's why I nicknamed it Kylo Ren. It's dark, moody, mysterious, and no one understands it. Now, how do astronomers find these exoplanets out in space? Well, we use the tools of the trade of all astronomers, telescopes, and light, and we use some very special telescopes, primarily space-based telescopes, telescopes that are orbiting out there in space. Now, one of these space-based telescopes that we used to find exoplanets was the KEPLER Space Telescope. Now, it's actually a retired telescope now. It ran out of fuel, so it's just floating around enjoying a nice space retirement. But before it did run out of fuel, it found us a lot of really cool exoplanets. And how it did this was it looked at a very specific sliver of our Milky Way galaxy and took a look at all of the stars in that particular sliver. Now, it's been replaced by another space telescope, the TESS telescope, the Transiting Exoplanet Survey Satellite. If you actually want to get involved in finding some exoplanets yourself, the data that is coming from the TESS telescope is actually being uploaded to a website, a citizen science site called planethunters.org. And it actually teaches you how to look for transits in the data. We'll get into what a transit is later on. And you can actually use this to find your own exoplanets. So if you want to get involved with planet hunting yourself, go to planethunters.org and you can learn even more. Now, one of the ways we use these telescopes to find exoplanets is just by taking a picture, just snapping a pic. We call this direct imaging. Now, this picture was taken by the Hubble Space Telescope, and what we actually had to do was block out the light from the star to see the exoplanets around it. And this method was also how they found the pink planet that we were talking about earlier. Another way that we find exoplanets is through something called the Doppler effect. Now, you've probably experienced the Doppler effect yourself walking down the street. Sometimes when we hear a loud sound, like for example, an airplane passing over or a siren from an ambulance or fire truck going by, we notice that as it gets closer to us and farther away, the sound actually seems to change. And that's the Doppler effect at work, the phenomenon that as a frequency of sound or light gets farther away from us, it changes. The waves actually change. And this happens with light as well. When we have a star that has exoplanets around it, the gravitational pull from those planets actually causes the star to wobble back and forth. And when we're looking at that star through a telescope, we see the frequency of light, the color of light, actually change as the star wobbles around. So we can see if a star has exoplanets based on whether or not it's wobbling back and forth. Getting a little dizzy. Another way that we find exoplanets is actually the method that was used by the Kepler Space Telescope that we were looking at before, and it is called the transit method. Now, the transit method isn't just hopping on a bus or a subway like we transit to and from different places in our city. The transit method is essentially having a staring contest with a star until we see a dip in brightness of the star. And this dip in brightness is a planet transiting in front of the star. We can learn a lot about an exoplanet based on this method, because as it transits in front of the star, we can actually take a look at the light that passes through the atmosphere of the planet through something called spectroscopy and split the light up like a prism into its different components, and through this learn what elements that it's made out of, like carbon, as we were talking about before. Now, with all of these different stars out in our galaxy and all of these different planets orbiting these stars in their own very own solar systems, how do we focus on the ones that might be best for life, best for alien life, or best for us to go visit and have a vacation, an interstellar vacation? Very exciting. Well, we split them up based on how habitable we think the planet might be. And this is based on something called a habitable zone, or the Goldilocks zone, where it's not too hot and it's not too cold. A very special planet is right in the middle of the habitable zone of our solar system. It's Earth, where we live. It has all the different things that we need to survive, and it's also exactly the right temperature. It's not too hot and it's not too cold, just like the soup or the bed that Goldilocks picked in the story of Goldilocks and the Three Bears. The habitable zone of a solar system depends on how big and how hot the sun is that all of the different planets orbit. So if you have a sun like our sun, the habitable zone is going to be about here, where our Earth is. But if you have a smaller sun, a smaller star that's cooler, like this one, the habitable zone is actually going to be closer to the star. And if you had a star that was even bigger and even hotter than our sun, and there's lots of stars out there in our galaxy like that, the habitable zone would be way farther away than it is in our solar system. We're going to take a journey from our home planet of Earth and go all the way over to another very different solar system. Now, this solar system orbits around a star in the constellation of Aquarius, which we can see right here, and we're going to zoom in to this star, which is called TRAPPIST-1. Now, TRAPPIST-1 is very different from our sun. It is an ultra-cool red dwarf star. Here it is right here. And that means it's a lot smaller and a lot cooler than our home star, the sun. And because of this, all the planets that orbit around it, there's 7 of them in total, are a lot closer to their star. But at least 4 of them are in the habitable zone, that Goldilocks zone, where it's not too hot and it's not too cold. And all 7 of them could potentially have liquid water on their surface. Because of these characteristics, some of these planets in the TRAPPIST-1 system may be very good candidates to find alien life outside of our solar system. They also might be really great places for those interstellar vacations, a good place for us to go visit and potentially live one day. The only problem with the TRAPPIST-1 system, if we could call it a problem, is that it's very far away from us. It's about 40 light years away from planet Earth. Now, when we talk about light years, it sounds like we're talking about a measurement of time, but we're actually talking about a measurement of distance. 1 light year is the amount of time it takes light to travel in 1 year, and it's equivalent to about 6 trillion miles, or 9.5 trillion kilometers. That is a very, very far distance. If we multiply 40 by 9.5 trillion kilometers, that's very, very far away. With our current space travel technology, our current spacecrafts, it would take us about 1.5 million years to get to the TRAPPIST-1 system, which is too bad, because it seems like a pretty cool spot to visit and explore. This is an artist rendition of what the surface of one of the TRAPPIST-1 planets might look like. As we can see, it's covered in rocks and ice and snow, just like the Arctic or the Antarctic here on Earth. It's too bad we can't go over here and visit and see if we can find some alien polar bears or penguins. Like the TRAPPIST-1 system, all of the different exoplanets in our galaxy that are potentially habitable, that is, good for us to live on, are really far away. It would take a really long time for us to get there. So we have to take care of the planet that we have that has everything we need to survive. Planet Earth. Look at it. It's perfect. It has an atmosphere that traps in air so we can breathe. It has oceans and fresh water for us to drink. All of these things that are necessary for us carbon-based life forms to have a really nice, healthy life. So we gotta take care of it, because it's our home planet in our beautiful neighborhood in our galaxy. Thanks for joining me in learning about exoplanets. I'm going to pass you over to Craft Commander Green, who is going to show us how to make watercolor exoplanets of our own. Take it away.
Thank you, Science Officer Millie. That was amazing. I really love learning about exoplanets because, like the planets in our own solar system, no two exoplanets are exactly the same. The sheer variety of what's out there really boggles my mind. What's even more incredible is that every single exoplanet, every planet in our solar system, in fact, everything in the universe, is made up of ingredients that we call elements. And there's only 115 of these elements that we know of. So you arrange them in different ways and you get different things, us included. Think of it like a cake. When you bake a cake, you need flour, whether it's gluten-free or 100% whole wheat. You need butter or margarine, sugar, sometimes eggs. But you take those same ingredients and use different amounts, putting them together in different ways, and you can get pancake mix, you can make biscuits, or even pizza dough. So just imagine how huge the universe is, and with these elements coming together in different ways, almost anything you can imagine must exist. So I like to imagine a planet covered in an ocean filled with purple algae, or planets that are orbiting small red stars. They could have black plants instead of green. It's incredible. My creative mind is starting to think maybe there could be a planet made of chocolate cake, or even better, a cheese planet. I'm getting hungry. I'm gonna grab a snack. You get yourselves prepared for our first spacecraft, watercolor planets. Let's go.
All right, everyone, here we go with our watercolor planet project. For this one, you'll need some watercolors. They don't have to be fancy, any kind will do. You'll also need some brushes. I recommend a tiny one, a medium one, and a larger one. You'll need a pencil and an eraser. I have my nice squishy eraser here. It's great. As far as paper goes, for this project, I highly recommend having watercolor paper. I've cut mine into 4 squares because we're painting 4 planets. You don't want to use regular paper because it could tear or buckle, so thicker, more absorbent paper is better. You also need a little glass to make your planet shapes, and you'll need some water. And whenever I use watercolor, I always like to have some paper towels handy. All right, we're ready to go. First up is making our planet shapes. So using this little 1-ounce glass, I'm creating some circles. Now you could go bigger if you like, but I recommend these smaller circles because they're easier to fill in with the paint, especially if you're just starting off with watercolor. So we've got our nice 4 little pages there ready to go. And we're gonna start with the pink planet. So for the pink planet, we're using a very classic watercolor technique called wet on wet. We start off by filling in the entire shape, the whole circle here, with clean water. Painting all the way to the edge there. Try not to go over the lines, because what will happen is wherever we put our paint, it will stay where the paper is already wet, so it won't actually bleed outside of those lines. Very cool. Now to make sure that it's wet, you just tilt your page and you'll see it sort of shine there. We're ready to go. I'm using a little bit of this nice pinky scarlety red, dropping it in, just sort of tapping it in there, and you can see how beautiful that is. Now, if I want it to be a lighter color pink, I actually just use water. I don't use white paint, just a little bit more water, and you'll have a lighter color here. Also, with more water, it really spreads. It looks so cool. Now, I'm leaving part of the planet white so that it looks like clouds, right? We've got these different light pink and darker pink and then white clouds swirling around the planet, really similar to how Jupiter looks, right? With those bands and belts of gases, all those different storms. Now I'm bringing in a little bit of an orangey red just to bring in a bit of a contrast, slight difference in color. You, of course, could bring in any color you like if you want some purple in there, maybe more red. But this is the pink planet, so I'm sticking with that palette. Just spreading it across to give it more of that kind of Jupiter look, those bands and belts of clouds. And I'll add a little bit more of the darker red in a second here, just to add more depth. Kind of making my circle a little bit better. And then dropping that in. I just love the way that looks. Cool, so here is our pink planet. Up next, we're going to be doing the diamond planet. Ooh. But instead of drawing diamonds, we're going to do some crystals, sort of these huge clusters of crystals growing out of this planet. So start by drawing the shape of a diamond. But now we're going to draw these long lines coming down from the bottom point. So these are parallel lines that we're going to join up at the bottom using a horizontal line that is the same angle as the one above it. So this way we're creating a 3D effect. Okay, so I'm going to keep drawing more of these crystal shapes all the way around, just randomly, some of them smaller, some of them bigger, and that creates a more interesting composition. I also like to keep things different by doing a different kind of crystal here, drawing that diamond shape but with a line right through it, creates kind of a pyramid, and a little crystal beside it so it looks like a cluster growing together. I also recommend drawing an odd number of crystals. So instead of 10, do 9. Instead of 7, do 5. For some reason, it's just more interesting when we draw odd numbers of elements in our drawing. Here I'm doing crystals, looking down on them, sort of bird's eye view, some small and some large. Excellent. Now we're going to erase some of those lines so that when we fill our crystals with paint, you won't see the pencil through it. That's why I like this little moldable eraser. I can get right in there. All right, redrawing my lines here before I start painting. Another thing I like to do before I start painting is prep my paint. So I get a little bit of fresh water here and I'm going to add color to it. So some of my crystals will be a nice bluey cyan color with a little bit of green. So these are like my cool colors that I'm using. These two mix really well together. And then for my other crystals, I will go with more pinky red colors and purple. So I'm using this kind of cool pinky red and purple. Now we're just filling in one side of the crystal with water, but this brush is way too big. So little brush, come in here and kick some butt. All right, little brush showing big brush who's boss. Okay, this is a delicate job. So first I'm going to squeegee off my brush here, bringing in a little bit of water to that side and then some paint. Now you'll notice how delicate I'm being. I'm using that very small brush to just gently bring in some blue, and I'm just painting one side of the crystal at a time. Bringing in some green now. Oh, but that's a bit too much. So if I want to take away some of that paint, I just dry off my brush and check it out. It's like a sponge. You can just soak up some of that paint, which is what I want to do, because when you're painting crystals, you want a little bit of that paper to show through, because crystals, they reflect and refract light. So you want to leave a lot of that white showing through, sort of to look shiny. Bringing in a bit more paint, but making sure that I stay away from the other side of the crystal where it's still wet so that they don't blend into each other. Okay, I'm going to continue painting, doing some red and pink crystals as well, and show you what it looks like at the end. Okay, so now that everything's dry, I'm going to take some more paint with less water so that it's brighter color, and I'm just going to draw some of the outlines here, or paint in some of the outlines. I've waited till all the crystals are really nice and dry, so this is a wet on dry technique, and this way we're adding a little bit of detail. We're really getting those crystals to pop. So that, everyone, is the diamond planet. Next up, we have the planet orbiting the two stars, the binary system. And for this, I'm going to paint what I think the landscape would look like if you were standing on the planet. So we're going to create a sunset sky. I've got some ultramarine blue and purple. I'm going to use sort of a pinky red, and then we're also going to use an orangey color so that we'll have a gradient going from that dark purpley blue to orange. Beautiful sunset. So this is really inspired by that scene from Star Wars A New Hope when Luke Skywalker is standing on Tatooine looking at the sunset, and we get those kind of colors off in the nice sky, and we see the two suns setting. It'll be really beautiful. But before we paint our sky, let's draw the landscape. So this is really easy. I'm just going to draw one line across the center of my circle. This represents the horizon line. So from this horizon, we'll see a sun setting. So there's our large sun setting. And then we have another sun just above it, a smaller one. Okay, now we are ready to paint. So we're going to use that wet on wet technique. I'm going to fill in just the sky area with water. Careful not to paint over the sun there. Okay, so now we can dab in a little bit of that purpley blue. And it is a good idea to dab it in at first, to just sort of drop in that paint. And then we can, oh, small brush wants to get in there because small brush needs to take over to do the delicate work around the suns. Okay, so we're bringing in that purpley blue, and that's the top of the sky. That's where it's a bit darker. And then it'll get gradually lighter as it gets as the paint gets closer to the sun setting there. So bringing in that beautiful pinky red. Now, if I were to use an orangey red, more of a tomato red, it would kind of look muddy as it blends in with the purple. So you want to use a cool red, but then you can bring in your orangey red because it will mix beautifully with the pinky red. Okay, so now we have our sunset gradient. We did it quickly, wet on wet, and now we're going to do the landscape. So this is the ground, the surface of the planet. And I'm going to do a sort of a desert surface so it looks even more like Tatooine. I'm mixing yellow ochre and a little bit of this warm brown together. Very nice. So you should wait until your sky dries a bit so that the land or the surface of the planet doesn't mix into the sky. And I'm going to start on the bottom here and work my way downwards. I'm doing this again quickly. I'm painting wet on dry paper, and this way you'll get a nice even color. So filling in all that sand, but I want to make it a little bit darker. So while it's still a bit wet, I'm bringing in a bit more of that darker or that warmer brown. Nice. I still want more contrast though. So now that sky is dried and the ground has dried, I'm actually going to bring in more of my sunset colors. I'm going in reverse, but you don't need to. You could start with the purple and come down to the orange, but I'm just starting this way, going from orange into my pinky red color. See, doesn't that look better? It just has a little more impact. It's really popping. Nice. Okay. And careful not to paint my suns there, and coming up into that beautiful purple. I think that looks a lot better. Just making it neat around the edges, and we're ready to paint our suns. You want to wait till that sky dries, okay? Really wait. I know it's hard to be patient, but wait till it dries, and then you can fill in your suns any color you like. Stars come in different colors. They come in colors like red, orange, yellow, blue, and white. So I'm making this sun that's setting a nice reddy orange color, and I'll make my other sun a yellow color. That's the color of our sun, actually. It's yellow. There we have it, the binary system planet. Lovely. All right. Now is our last planet. We're doing the black gas planet. For this one, we're going to do wet on wet, but we're starting with, instead of clean water, sort of a grayish color water. And I'm painting outside of the edges here, so around, sort of extending that water so that the atmosphere of this planet is really puffy and extended, meaning that it comes far away from the surface of the planet. Now we can add our black paint. So lots of paint, not as much water, so we get a really dark black here, just dabbing it in and letting it spread out to create that atmosphere. You can also add in other colors. I'm going to put in just a tiny bit of blue. So here we have our black gas planet. Now that we finished all 4 of our exoplanets, I'd love to challenge you to come up with your own, use your imagination, and then share what you came up with in the comments below. Also, you can hashtag your work spacecraft exoplanets. Don't forget to subscribe and like this channel, and come back next week when we talk about astronauts in isolation. Until then, stay curious and stay creative.